Investigating parallel and perpendicular lines. Two lines that are parallel have the same slope or the same gradient. In other words, the gradient of line 1 will be equal to the gradient of line 2. Parallel lines share the same gradient. M1 is equal to M2. If I knew that the equation of a line was y equals 3x plus 1, I can see here that the gradient, or m, of the line is equal to 3. If I was asked to give another equation of a line that is parallel to y equals 3x plus 1, I can write any equation that has a gradient of 3. Y equals 3x minus 2, it would be parallel. Y equals 3x is parallel. Y equals 3x plus 10 is parallel. Why? Because they all share a gradient of 3. How about perpendicular lines? Perpendicular lines meet at right angles. So here's one straight line. The line perpendicular to that would meet it at a right angle. When two lines are perpendicular, the gradient of one multiplied by the gradient of the second is equal to -1. So if I was asked to give an equation of a line that is perpendicular to y equals 2x minus 1, I would first identify the gradient. The gradient is 2. I know that the gradient of the first line is 2. The gradient of the first line by the gradient of the second line is equal to -1. Gradient 1 is 2. 2 times m2 equals -1. To undo the times 2, divide both sides by 2. The gradient of the second line is -0.5 or -0.5. Therefore, I can write the equation of any line, and it will be perpendicular to y equals 2x minus 1, provided it has a gradient of -0.5. For example, y equals -0.5 x plus 1, y equals -0.5 x take 2, y equals -0.5 x plus 100. Here is a slightly harder question. I am being asked to determine whether 2y equals 4x take 9 and 3y take 6x plus 5 equals 0 are parallel to each other. To solve this question, I must determine the gradient of each line. 2y equals 4x take 9. To change it into the format y equals mx plus c, I must divide both sides of the equation by 2. Then I can see y equals 2x take 4.5. The gradient of this line, the first line, is 2, mx. I now look at the second equation. 3y take 6x plus 5 equals 0. Once again, I want to get it into the form y equals mx plus c. To do this, I will first subtract 5 from both sides of the equation. 3y take 6x equals -5. To undo the take 6x, I will add 6x to both sides of the equation. 3y equals -5 plus 6x. Finally, to undo the times by 3, I will divide both sides of the equation by. When I simplify this, y equals -5 divided by 3 plus 2x. If I rearrange this so that mx is first, mx plus c, I can see that the gradient of this second line is 2. The gradient of the first line was 2. The gradient of the second line is 2. M1 equals M2. Therefore, the lines are parallel. Proving two lines are perpendicular. I've been asked to show that y equals 3x minus 10 is perpendicular to 6y plus 2x plus 12 equals 0. I need to recall that when two lines are perpendicular, the gradients multiply to give -1. Looking at my first equation, y equals 3x minus 10, it is easy to see that the gradient of this line is 3. For the second equation, I will need to rearrange it first into the form y equals mx plus c before I can see the gradient easily. I begin. My first step will be to subtract 12 from both sides. 6y plus 2x equals -12. Next step, I will subtract 2x from both sides, giving 6y equals -12 minus 2x. Finally, I will divide both sides by 6 in order to get y by itself. This gives y equals -2 take 1/3 x, or y equals -1/3 x take 2. The gradient of this line can now be easily seen. The gradient of the second line is -1/3. Are the lines perpendicular? They are perpendicular if the gradient of the first multiplied by the gradient of the second equals -1. The gradient of the first was 3. 3 times the gradient of the second line was -1/3. Does 3 times -1/3 equal -1? Yes, it does. Therefore, the two lines are perpendicular. Please now try questions 3 to 12 from pages 36 to 37 of your text.